Hello everyone. I'm proud to introduce the next team of 6 who have been working diligently on their project for the past couple months. Please welcome the Meals on Wheels team.
Okay, imagine that here we have a picture of a man who is sad and hungry. And imagine that here we have a picture of a man that is happy and fed. If this were your grandfather or grandmother, which of the two states of beings would you prefer for them? Well, that was hopefully an easy answer. What is not so easy is how to best develop a system in order how to get food to them and so that they don't go hungry. That's where we as a team came in to ensure that this was done. My name is Eric Ali.
My name is Jawad Aramis.
My name is Faiz Al-Faiz.
My name is Julian De La Rosa.
My name is Ali Alamir.
My name is Loy Alhurst.
You all did it real quickly, remember? Slow down. Okay.
Meals on Wheels is a non-profit organization located in San Antonio, Oregon, Bay County. It was established in 1977 by two San Antonio churches, St. John Lutheran Church and the Grace Lutheran Church. It's a service company that delivers meals for seniors who cannot make food for themselves or walking to a grocery store. The company helps seniors community by sending meals every weekday by sending out literature each weekday. And also the company checks on their clients when they deliver meals to make sure they have been received. Organization help the seniors to be healthier and more independent on their own home.
A typical working days of Meals on Wheels would be that the worker prepares the meal early in the morning and group them and put them inside a cooler. After that, they put the cooler on a car to transport the meals from the kitchen to the trucks. The trucks have built-in oven to maintain the temperature of the meals. Currently, Meals on Wheels have 29 trucks, and each truck has the capacity of 250 meals. The meals are delivered from Meals on Wheels to all 59 different sites. Most of them are church. And then drivers and volunteers receive the meals from each site and deliver them to the clients. They have 3 hours time window to deliver all the meals. The current operation costs Meals on Wheels $46,000 every month for only delivering the meals.
One of the other project ideas we had for Meals on Wheels came about from the concept of the volunteers picking up the meals. When it came to the volunteers picking up the meals, sometimes there was an issue where, for whatever reason, the meals were left behind in some cases. And in that case, Meals on Wheels would unfortunately not find out until much later that the meals weren't delivered in that case. So the idea was then to create an application that be able to allow Meals on Wheels to find out when those meals were delivered. The idea then, however, was what would the application be on? Would it be on Apple or would it be on Android? So then the next idea then was to create a web application. With the web application, it wouldn't necessarily matter what the type of device they use, whether it's phone, tablets, or in some cases just anything that the volunteers could use, they'd be able to have access to the web application.
Mr. Snyder from Meals on Wheels provided us the data involved addresses and demand. Based on that, we were able to calculate the necessary demand for 59 sites to be input for PRP software. And then we use ZMap to create a visual representation of the site and get better understanding. We also use Google Maps to measure the distance from Meals on Wheels to each individual site and from each site to the other. And that allowed us to create a 60 by 60 matrix, which has 3,600 cells of distance. Another necessary component in order to use VRB software, we needed to convert the distance from miles to longitude and latitude by using VRB spreadsheet solver. And then we utilized VRB software and vehicle routing problem method by generating saving matrix. And then we used Octanap to find a good solution.
So the problem with our solution is it doesn't account for the time it takes to unload the meals. That is the reason that we built a simulation in ProModel to account for the amount of time they would unload at each site and the amount of time it would take to do the route.
So in terms of actual software methodologies used, I use something called the Agile methodology, which would allow me essentially to break up the project into sprints or iterations that would be able to allow me to work on this project in general. I also kept in mind something called the 3-tier model, which essentially split the design into a design tier, a logic tier, and a data tier. In terms of tools that I use something that's called WAMP Server, which is a software stack that has multiple programs and tools built into it that allow me to go ahead and work on this application. One of the tools mainly being PHP MyAdmin, which would allow me to interact and work with the database for the project, and also Apache Server, which would allow me to display the application using its virtual host. This right here is a screenshot of the interface that's used for Apache Server essentially, which allowed me to look at the documentation, but most importantly, be able to display the virtual hosting and allow others to be able to actually use the application. This is another interface screenshot of PHP MyAdmin, which was what allowed me to go ahead and edit, create, and do anything I needed to with my data tables. Another tool that I used was Visual Studio, which is the IDE which allowed me to go ahead and interact with the code. And from there, I'd be able to not only interact with it, but also test it and connect it with the database. This is another screenshot that should be displaying essentially just what I worked on, how it looks in terms of the split design, where I can work on the design of the application, but also on the actual code.
So as mentioned earlier, they have 29 trucks and it costs $46,000 to maintain their monthly operation. With our new solution using Dr. Snyder's ERP software, we reduced it down to 10 trucks and the total cost monthly would be $15,000. In total, this would be a 66% saving for the company. With our other solution, which was VRP by generating saving matrix, we reduced the monthly cost from $46,000 to $17,000, and we saved 62%. Also in this one, we were able to combine several sites and get it down to 47 total. And with those two solutions, we inputted them into Optimap in order to make our solution even better to make sure that every route was as short as possible.
Following that will be some of the screenshots for the actual interface. So again, the idea behind the application was to go ahead and send a message to Meals on Wheels, letting them know what meals were delivered and such. The application on the home page would allow volunteers to essentially search for their groups as the meals are split into groups of meal packages that they would then deliver, and thus send a message to Meals on Wheels later using the application to let them know not only when the meals were delivered, but a time and date stamp to let them know, yes, the meals were in fact delivered. Here's another image of the dashboard that let volunteers interact with the various pages of the application. But the main important pages also are the group and client pages. Those are two pages that would essentially only employees would be allowed to access, as those pages would allow Meals on Wheels to enter in the information that they wish involving the clients, and also edit the information added or deleted and such. And from there, they'd be able to allow the volunteers to access the information they need to be able to deliver it. From there, then they would send the message, and these pages are also insured by password protection, because we would want to ensure that no volunteer would be able to just edit these pages as they wish. Testing was also done on the application in terms of general volunteers and also different age groups to get an idea of how people would interact with the system. From the feedback I had essentially obtained, it gave me ideas of what still needs to be improved on the application and what final changes still need to be actually made. From these changes, it also gives other ideas of maybe what else can be done with this project and what future work could be done.
We observe to calculate the average time that take the drivers to unload the meals in each location. And then we multiply by 0.5 to get the minimum, and we multiply by 1.5 to get the maximum. Then we apply it to triangle distribution. We utilize the Optimap to get the minimum time to travel between distance to other distance. And then we use Google Map to calculate the maximum time. Then we get the average time, and then we apply it in triangle distribution.
So now that that was done, we had our averages, our highs and lows, we can now actually build our simulation. In our simulation, and for example, we'll be taking just into account one route, it would have location 1 and 2, and of course Meals on Wheels. It would have an entity, which would be the driver, and we would have him travel on a path network. In the path network is where the triangular distribution was added in order to best mimic reality. And we also had the meal variables inside the variable. So meal 1 was 145 meals, and for meal 2 was 11 meals. And for meal 1, we go to location 1, for meal 2, we go to location 2, and this would also best mimic reality. And this is a video of our actual simulation that is running, but there you go. And that's what it looks like, the simulation actually running. And in this simulation, it's a little sped up, but it does give you the time in reality. And it meant the 3-hour time constraint, which was our goal.
The result we got, the average time in the system is that the driver traveled from Meals on Wheels and back to Meals on Wheels. And the average time in moving luggage that the drivers take travel from the location to other location. And the average time in the operation is the driver take to unload the meals in the location.
Another important factor of the project is to ensure the safety of the drivers and the volunteer. This is where ergonomics comes into play. The National Institute for Occupational Safety and Health always recommends a load constant of 51 pounds. But that's going to be under ideal condition, which is safe, which is 75% safe for females and 90% safe for females. NIOSH goes further and provides you with the NIOSH lifting equation calculator on their website, where you need to include the horizontal distance, the horizontal location, vertical location, and so on. And there, when you include all the inputs, if the results of the lifting index comes out, does not exceed 1, then that load is safe to be lifted. Another good tool to use is the Snook table calculator for pushing an object. Here, it gives you a recommendation of how much load you can put on a cart and push it safely.
There are 1,800 meals that are delivered to unique address. They are independent from the 59 sites that we built with in our project. We would like to give the future students the opportunity to work to complete the project. And we would like to thank Mr. Snyder for giving us the opportunity to do our senior design with Meals on Wheels. And we would like to thank our both professor, Dr. Morris and Dr. Acton, for helping us. Any questions?
All right, any questions, anyone? We got time for maybe 1 or 2 questions. Mr. Snyder, any comments, sir?
I won't read the report, we'll ask some questions then. Actually, of course, study more, how you guys down to the consolidation, reduce some of the sites, and understand that better. Really good, thank you guys.
All right, thank you, team. Yeah, that photo is about 10 minutes old, right?